It all began with a dream that stretched beyond the boundaries of our world, reaching out into the infinite darkness of space. For centuries humanity has looked up at the night sky, wondering what lies beyond those distant points of light. This dream was to reach the giants of our solar system, to see with our own eyes the mysterious worlds that had only been tiny dots in our telescopes. In 1977, humanity took a bold step and launched Voyager 2, a small spacecraft, yet a vessel of immense hope. It was packed with scientific instruments and a golden record, a message in a bottle cast into the cosmic ocean, carrying greetings, music and images from Earth to any who might find it. Its mission was made possible by a rare planetary alignment, a cosmic opportunity that comes only once every 176 years. Voyager 2 would use this alignment to visit Jupiter, Saturn, Uranus, and Neptune, an unprecedented journey to the outer planets. This was more than just a photo op. It was our first real step into the unknown, a leap of faith into the vastness, hoping to uncover secrets hidden for billions of years. The world was different then. No internet, no smartphones, just raw ambition, slide rules, and the relentless ingenuity of the engineers at NASA's Jet Propulsion Laboratory. Every calculation was painstaking, every decision critical. Voyager 2's path was a masterstroke of celestial mechanics, using gravity assists, planetary slingshots to gain speed and change course, a dance with gravity that allowed it to visit 4 planets on a single mission. The launch marked the start of an epic journey. As the rocket thundered into the sky, Voyager 2 became a symbol of human curiosity, hope, and the unyielding desire to explore. Alone in the vastness, it carried our questions and dreams, venturing where no probe had gone before. It was a silent ambassador, braving the cold and darkness, pushing ever farther from home. Its journey would reshape our understanding of the solar system and ourselves. Each new discovery sent back to Earth was a revelation, a reminder of how much there is still to learn. The little probe was on its way, a silent traveler on the grandest of all voyages, carrying with it the hopes, dreams, and curiosity of an entire planet, destined to wander the stars long after we are gone. Voyager 2's first stop, Jupiter, 1979. As the spacecraft approached the giant planet, anticipation ran high among scientists and the public alike. No one had ever seen Jupiter up close in such detail before, and Voyager 2 was about to change that forever. It revealed the planet's violent storms, towering clouds swirling in a chaotic dance, lightning crackling through the atmosphere, and the iconic Great Red Spot, a hurricane larger than Earth itself, raging for centuries. And on Io, one of Jupiter's moons, Voyager 2 captured the first active volcanoes ever seen beyond Earth. Plumes of sulfur and ash erupted hundreds of kilometers high, painting Io's surface in wild colors and revealing a world more geologically alive than anyone had imagined. Next, Saturn. Its rings were intricate, dynamic, and mysterious. Not solid, but a swirling dance of icy particles. Voyager 2's close-up images showed countless ringlets and gaps, some shaped by tiny, unseen moons, and hinted at the complex forces sculpting this beautiful system. Voyager 2's images of moons like Enceladus and Tethys hinted at violent histories, fractured surfaces, ancient craters, and evidence of past geological upheaval. These moons, once thought to be cold and dead, now seem full of secrets. In 1986, it became the only spacecraft to visit Uranus, a tilted, aquamarine world with extreme seasons and a bizarre magnetic storm. Uranus spun on its side, its poles pointing almost directly at the sun, creating years of darkness and light. Voyager 2's instruments detected a magnetic field twisted and offset, unlike any other planet. Voyager 2 discovered new moons, rings, and mysteries at every turn. 11 new moons and 2 faint rings were added to Uranus's family, each with its own story, each reshaping our understanding of the planet's strange environment. Then, Neptune, deep blue, with the fastest winds in the solar system and a massive storm called the Great Dark Spot. Voyager 2's cameras revealed a world of wild weather, where winds howled at over 1,000 miles per hour, and clouds raced across the sky. It found clumpy rings, new moons, and witnessed geysers erupting from Triton's frozen surface. Triton, Neptune's largest moon, spouted icy plumes into space, hinting at a hidden active interior and raising new questions about where life might exist. Each encounter transformed our view of the outer planets from distant dots to dynamic worlds. Voyager 2's images replaced blurry smudges with breathtaking detail, revealing atmospheres, storms, and landscapes that no one had ever imagined. After Neptune, the planetary tour was over, but Voyager 2's journey was far from finished. The spacecraft, now a veteran explorer, set its sights on the edge of the solar system, carrying humanity's curiosity into the unknown. It had rewritten the map of our solar system, filling in blank spaces with discoveries and forever changing how we see our cosmic neighborhood. The probe pressed on into the unknown, its instruments still listening for whispers from the stars and sending back data from the edge of interstellar space. Its greatest discoveries still lay ahead, as Voyager 2 continued its silent voyage, carrying our hopes and questions into the vastness beyond the planets. Decades later, Voyager 2 sailed beyond the planets, entering interstellar space in 2018. By the mid-2020s, it was over 13 billion miles from Earth, its signals taking nearly a day to reach us. Then, in 2025, NASA's Deep Space Network detected something bizarre. Voyager 2's signal suggested it had reversed direction. A U-turn in interstellar space? Impossible. Voyager 2 had no way to do that. Had it hit something? Was it a glitch? Theories swirled. Engineers checked everything. On Earth and on the spacecraft, the data defied explanation. For weeks, the world's most distant explorer sent signals that broke the rules of physics. The mystery became a top priority. Something extraordinary was happening out there. We just had to figure out what. Communicating with Voyager 2 is a slow, delicate process. Signals take nearly a day each way. Imagine sending a message and waiting almost 18 hours just to hear a reply. The vastness of space stretches every conversation to the limits of patience and technology. The Deep Space Network's giant antennas in California, Spain, and Australia listen for its faint whispers. These massive dishes are humanity's ears, straining to catch the tiniest signals from the edge of our solar system, working in perfect coordination around the clock. By the time its signal reaches Earth, it's billions of times weaker than a watch battery. Detecting it is like trying to hear a pin drop during a thunderstorm, requiring extraordinary sensitivity and precision. Every bit of data is precious, every command double-checked. Teams pore over each transmission, knowing that a single error could mean losing contact forever with a spacecraft billions of miles away. That's why the sudden Doppler shift, a sign of reversed velocity, was so alarming. It was as if Voyager 2 had suddenly changed course, defying all expectations and calculations. Scientists ruled out errors on Earth. The anomaly was real, coming from Voyager 2's direction. The data was checked and rechecked, but the mystery only deepened. The probe, nearly 50 years old, had survived cosmic rays and the harshest conditions. It had traveled farther than any human-made object, enduring the cold and radiation of deep space. Was it a system failure, a sensor glitch, or something else entirely, something no one had ever seen before? The possibilities were as vast as space itself. The team crafted careful commands, hoping for answers. Each exchange took days. Every instruction was sent with hope and anxiety, knowing that the fate of Voyager 2 hung in the balance. The world waited, watching for a clue from the edge of the solar system. News outlets buzzed with speculation, and people everywhere wondered what Voyager 2 might reveal next. The answer, when it came, was stranger than anyone expected. Voyager 2 had once again challenged our understanding of the universe, reminding us how much mystery still lies beyond our reach. While engineers puzzled over Voyager 2, astronomers using Hubble tracked a massive storm on Neptune. The storm, expected to drift south and dissipate, suddenly reversed course, an unprecedented event. At the same time, Voyager 2's signal anomaly began. Comparing notes, the teams realized the timing matched perfectly. The U-turn wasn't real. It was a ghost in the data, triggered by Neptune's storm. The storm's reversal sent a powerful disturbance through Neptune's magnetosphere, rippling out into space. Voyager 2's instruments detected this change, and its software misread it as a change in velocity. The probe had become a weather sensor, picking up a planetary event from billions of miles away. It wasn't a U-turn, it was a cosmic weather report. The mystery's resolution was a profound lesson. A storm on Neptune had sent ripples through space, detected by a probe billions of miles away. Planets aren't isolated, they interact, sending energy and particles across the solar system. Hubble saw the storm, Voyager 2 felt its effects. It was like seeing lightning and hearing thunder, separated by cosmic distance. This event forced scientists to rethink the reach of planetary weather. Even distant storms can influence the interstellar environment. Every new discovery reminds us how much we still have to learn. Voyager 2's journey is a triumph of science and engineering. Built for a 5-year mission, it's lasted nearly 50, revealing the outer planets as vibrant, dynamic worlds. It discovered volcanoes, new moons, and the wild weather of distant giants. Now, it measures the interstellar medium, sending real data from beyond the sun's influence. Its golden record carries our greetings and music, a message to the cosmos. Voyager 2 is our scout, our ambassador, and our legacy. Its data will inspire generations. It proves that with ingenuity, even the smallest probe can change our view of the universe. Its journey continues, far beyond its original mission. Voyager 2's story is ultimately about us, our curiosity, our drive to explore. It reminds us of our place in the cosmos, a tiny blue dot in a vast, mysterious ocean. Its discoveries have shown us worlds of unimaginable scale and beauty, but also the fragility of our own. The Neptune anomaly is a metaphor for science faced with the impossible. We investigate, collaborate, and discover. Voyager 2 is a beacon of hope, proof that exploration endures. As it drifts through the galaxy, it carries a piece of humanity with it. One day it will fall silent, but its legacy is eternal. It will wander the Milky Way for eons, a testament to our curiosity. Once, a small world looked up and decided to explore. That is Voyager 2's greatest legacy.